Alright, we are live. Let me just check the mic again. Maybe the mic isn't working? Is the mic working? The mic should be working, I don't know, I don't hear myself. Yeah, it is working, alright. Okay, let's get into this. So, yeah, the mic works. Alright, uh, hey, thanks for this one. Alright, so we ended up abstracting the shader. Yesterday we just added these two interfaces to our render interface. So what we're doing at the moment is writing a C++ interface and abstracting the code that is written in C. So the first two session of this was spent on abstracting the lifetime. So our lifetime is handled by this render aware unique putter right now, so I don't need to remove the um, call the remove functions by myself. And then we abstracted out this command system that they have for the rendering, uh, which is, yeah, this is the graphics command. And then we added two interfaces to add and remove shaders. So the add shader just takes a shader descriptor and returns a handle to that shader descriptor. Remove shader just takes the shader handle and removes the shader. And the lifetime still is handled by this render aware unique putter, which we've implemented. So yeah, I'm trying to just get a skybox rendered. So as soon as I get a skybox rendered, I'm going to kinda try to remove some of this code. So I'm copy pasting a lot of code from the first transformations example, and I'm almost doing the same routine until I find the structure, and then I put it in the proper structure. Alright, let's go and abstract out the sampler then, I guess. So same as the shader, I'm going to provide kind of the same abstraction for the sampler for almost every almost component that the render supports. So it's gonna be the add sampler. It is going to take sampler descriptor. Here we go, and it's going to create a sampler, remove sampler here, sampler, and that is our sampler descriptor. So what I'm doing is just going with the same design as we did for the shader. I'm just adding two interfaces for adding samplers and removing samplers. And I don't like this. I don't like using the unordered map for this, but for now, I am limited by my design. So the problem with the unordered map, so the reason I'm using unordered map, uh, I'm trying to achieve zero overhead access to my shader slash sampler from the handle, and that is why I'm using UintPTR. I'm just returning the pointer in UintPTR as the handle, so the cost of getting back my shader or sampler is just a reinterpret cast, which is literally nothing. You don't pay anything for that. And to remove it, I need to have it in some container with some key. The key is probably going to be the shader handle, and from that I'm gonna get shader and remove it. So that is why we're using unordered map here, and it is causing me some problems with this. Like I have to use stud move here to move this shader footer or sampler footer back to container. Anyways, let's get to coding. So yeah, this is also some copy pasting. Maybe I will abstract this out later as well. Let's see how it goes, because I'm literally copy pasting these two functions over and over again. Anyway, we have the interface for sampler, so we're going to add sampler here. I'm currently not keeping my handles here, so I'm adding the shader here. I'm just letting the handle go, but later on, to use these shaders or samplers, I'm going to need the handler, so I will, when needed, I will keep them inside the example class here. This render byte example. Then maybe I need to change that render byte. Render byte name, because it's no more rendering just byte. It's going to render a skybox. So anyways, that is the sampler right there. We added the sampler, and what we're doing here, shaders. So we're adding root signatures, shader count. Same is gonna be, the design is going to be the same with the root signatures. Maybe I'm going to, I don't know, I could like get the root signatures from the at the construction of the shader. That is one way of doing that. I don't think this is going to take that long, because yeah, let's just do this the easiest way, which is, let me see, skybox VB descriptor. One problem I have with returning uint footers as handles is that this is not type safe anymore. This could be the handle of a shader or a sampler. I just removed the type safety there. I don't know what to do about that. Maybe I could just avoid this this reinterpret cast that I'm doing here. Maybe I could just avoid that. We'll go about that maybe later on. For now, this works. We're going to use the same pattern for root signature. So that is root signature there at descriptor set. So the descriptor set virtually takes one root signature. Let's see what is descriptor set descriptor. A bunch of root signatures and descriptor update frequency. Is this a bunch of root signatures or single root signature? The reason I'm thinking about this is that maybe I can just skip providing an interface for root signatures, because if each root signature is going to have a corresponding descriptor set, why are these not a single thing? This could be a single construct. And from what I'm seeing in the descriptor set descriptor, it just takes one single root signature. So maybe I could like take, like this would be a descriptor set. What I would need to create a descriptor set would be a root signature descriptor, which is that, and then update frequency, and what else? Max set node index. Virtually these two, but I don't think we're going to need them. Maybe we are. Let me check. Root signature. Set uniforms. Does this? Alright, so I don't get what this number is here. So it says mmax sets. What does that mean? Mmax sets. Let's check what we have inside our descriptor set. I don't know. I have no idea what that mmax set means. Yeah, I'm going to take that as input as well. So our add descriptor set would just get a root signature descriptor. Root signature descriptor, which is this. And signature. I don't have spelling check on in this. I need to turn this spell check on. I'm not that good of a speller. Anyways, then what I'm going to need is the update frequency, which is of type descriptor update frequency. Descriptor. Why is the IntelliSense not helping me here? Okay. Update frequency. And the last thing would be the image count, which is size t to me, because it is a count. We will do a static cast to deal with the narrowing. max descriptor set. I don't know what this number is and what it is used for, but we will figure it out. Anyways, that is what that is. I'm going to create a new construct here, which is going to be a class, and what it's going to be is descriptor set. Let's fix the names. Okay, so our descriptor set is going to have a unique PDR, unique putter of descriptor set itself. Descriptor set. And remove descriptor here. So that's our descriptor set. And it is going to have a root signature inside it. Because from what I'm understanding, a root signature of itself is of no meaning. Or is it? Maybe it is not the case. Let me check. Let's see what this root, where this root signature is used. Remove root signature, pipeline settings. So root signature is used in pipeline settings. There is this design issue, I guess, here. Root signature. It is using the root signature, but it is not using the descriptor set. That is what is bothering me right now. Like, alright, who cares? Let's go ahead with this. We will change the interface as new features just creep. Root signature. I'm trying to hide root signature. I don't see a reason for it. But if we actually need to do to somewhere in along the way we need to access the root signature, I'm gonna need to provide a way to actually access it. For now we're not able to access root signature. We're just abstracting it away. The user doesn't need to know about the root signature. Anyways, that is the interface I'm going with. We're going to have a map here. Right, let's write a constructor for this. So what our constructor is going to do is going to first construct our root signature. See, no, I didn't want to do that. So we first construct our root signature, and then it is time to construct our descriptor set. So we're going to get these as input, which is root signature descriptor, update frequency, and max descriptor set. So add root signature. Root signature render goes first, I believe. Yeah, render at root signature, and then our parameter, which is root signature descriptor. And then we will go for constructing render reference. I'm going to need the render reference here. So yeah, we're going to construct this descriptor set. We're going to need the pointer to our root signature here. So add descriptor set. There goes the help from IntelliSense, and we're going to construct a descriptor set descriptor, which is this, and it's constructed easily. So the first parameter would be the root signature. Where's my root signature? .get. The second parameter would be the rest of this update frequency and max descriptor set. Alright, that is our construct, that is our descriptor set. We've just hidden the root signature from user. I don't think the user is going to need it, but in case it does, we will try to address that later on. So I still don't know what that image count multiplied by 2 is doing there. Max sets. I have no idea what that is. But that is not the issue here. Max sets, let's keep the naming as it was before. So our add descriptor set takes these as input, and it is supposed to return a descriptor set. And we are going to provide a interface here, which is going to be get descriptor set handle. Do we have an issue here? Yes, we do. Yep. So there's going to be this interface uIntPutter to get descriptor set handle. We're going to use this to put our descriptor set into a map, and of course provide the user with a handle to our descriptor set. So what it's going to do is return the descriptor set putter. Of course we're doing our interpret class here. There goes that, and here goes that, and this is cost right there. Anyways, yeah. So what we're going to do is simply construct the descriptor set. Okay, we're going to need to change this name because it does, I guess, conflict with that. So we need to change this name. IYP descriptor set. That is the way we're going for now. These name changes are code breaking. We can later on change those names. These are just private types. That doesn't really matter. So So I'm gonna construct a descriptor set here. Just gonna pass render footer like get. Of course, we're going to pass a reference to it. Then we're going to pass the update frequency and the max set. So we have a descriptor set here. Then I'm going to get the descriptor set handle here. And I'm gonna just straight up get descriptor set handle. My Intel isn't really helping today. I don't know why that is. Set handle. I don't know why it's not helping today. Anyways, we're going to have an unordered map of these descriptor sets. And that is that, descriptor sets. You might be wondering why I'm doing all this job. Just write the damn code, you might say. This is going to, you will see the result later on. This is going to lead into a better code, more readable. And if you don't believe it, well, maybe you will have to wait till the end. I'm kinda sure this will result in bug-free code. And that is that. Let's move on with this. Yeah, my design is going to be lacking some stuff, some constructs. But yeah, we will get to that later. I'm quite sure that we are indeed lacking some stuff here in the design. But we'll fix that. There is no, our hands are not tied. Piece static sampler, skybox. Names. What is the static sampler names? That is that. Shaders. Yeah, like I believe all this is just shader related stuff. There is no reason that I shouldn't be passing these at construction. At the construction of the shader. We'll go about doing so later. Let's just get a code to compile and actually render something. And then seeing the big picture, we can abstract out some other constructs in the code, make it easier. Pointer to sampler. Alright. Let's just go with this for now. That's expert, however. There goes that, and the sampler skybox. Of course, the shaders. So we just added the shader here. Now we need the output. So this reinterpret cast here, right, just shows that this needs to be part of the render itself, because the user does not know that this handle is of type shader pointer, and that it can actually do this reinterpret cast that I did right here. So yeah, the user does not know about that. The renderer does, and so this is something the renderer should be doing rather than the user. And one other thing is static samplers. That is the sampler here. To sampler handle. So what I'm doing here is just trying to match my interface with the old code so that I can get a skybox rendered. Again, here the user doesn't know that this sampler handle is of type sampler, so doing that, this is something that these two lines, the render should be doing, not the user. Root signature descriptor. Samplers. What is wrong with that code? That should work just fine, I believe. Alright, that works. Anyways, I'm now going to tell the renderer to give me a descriptor set, which is going to take the root descriptor here with the update frequency, and that one, which I don't know what it does, and then another for this, which again I don't know what it does, but I believe all of this code should be done inside the render. This 6 depends on the root chain length, which the swap chain length, which the render is aware of. So this is definitely something related to that command. I need to try to figure out how to abstract that out. I don't think the user needs to know about this. Anyways, let's see if this compiles. We have done another code. We have written another code. Maybe it doesn't. And surely it doesn't. What's it saying? IYP descriptor said no overload function to take 3 arguments. Oh yeah, it takes more than 3 arguments. You are correct, sir. The scripture said it also takes the root signature of the scripture. Yeah, we don't have sampler handle anymore. Okay. This is my last, I believe, last error. Oh, it's not. Alright, yeah, I did rename this. Motors. Yeah, that is the narrowing we had there. We need to static cast this. There goes that. This should compile and work. And it compiles. Let's see if it actually works as well. And of course, we are doing some memory leaks. I don't know why that is. I don't remember why that is. Oh yeah, I remember why that is. Because we're loading some shaders here. Some textures here. And we haven't abstracted out the resource loader yet. So the resource loader needs to, yeah, the resources that we load, we need to remove them by hand for now. So that is why I'm getting some memory leaks. Let's move on, however. Descriptor, we've done that code. Sphere points. I don't wanna draw any spheres. I just want skybox. So that is what this code is going to do. Copy and paste it right here. And also I believe I need this code here. I'm gonna be missing some variables here. I will fix that later. I don't have any UIs yet, so parameters now create FPS camera controller that I need. So I'm just copy pasting all the code that I need here, and then I will get it to compile, and then I will extract out the constructs in it. Set motion parameter, what is that? So this part of the code I've never seen. So this is the first time I'm handling this part of the code. That is why I'm a bit weirded out by the code. Yeah, you're going to need all that code. Alright, yeah, you would be telling me What are you doing? You're just confessing all that. Yes, I am. I will abstract things out soon. Don't worry about that. I'm not going to leave this code to stay here. I'm definitely going to abstract out these. So what I'm figuring out that should be abstracted out here. Let's see. Vertex buffer descriptor. I don't know if I can actually abstract that out as a part of the renderer because it is using the add resource, which is the resource loader part of the engine. So that is not the part of, that's a part of the renderer itself. The vertex buffer, that is the output of this add resource. And where is this vertex buffer actually used? Nowhere. Nowhere here. But I bet it is used at least in the nope. I bet it is used in the draw function. Let's check that out. Yeah, it is using the draw function. So that is the resource we're going to draw. UV descriptor, I don't know what this is. I might have copied it unnecessarily, but I don't think so. I think this is the uniform buffer descriptor. I believe this should be abstracted out somehow as well, but it is not part of the renderer because it is still using the add resource thing which is for the that is for the resource loader, so not part of the renderer itself. And then we have camera. I don't know what camera. Add GPU profiler. That is part of the renderer. I'm not going to add GPU profiler for now. Add actions. App UI. Alright. Button down. I'm going to remove these actions that are for the UI of the game. I don't have UI for now. I'm not going to support it. Let me see. Modulated. Action descriptor. What is this action descriptor is doing? Position. Blah blah. This is doing nothing. Alright, that is doing nothing. So what is this? So I may need to use that virtual joystick there. I removed the code for the virtual joystick yesterday because I did not know what it was. Float left stick, float right, button, no. The camera controls a few. Let me see what this is doing here. So yeah, I believe I'm going to need that joystick code that I removed. Free. This is that virtual joystick here. Circle path, architecture. Maybe not, maybe I don't need this. Let's skip over this. Let's skip over this for now. Let's skip over all the app actions for now, actually. Let's just get the rendering going. Prepare descriptor sets, so skybox texture. Alright, so I need to do this. This needs to be done inside the that needs to be done inside the renderer. Same as these. These are the set descriptor sets. Yeah. Okay, that's all the code that we need for now in our installation. Let's just patch this together like the easiest way we can. I don't want to put much time. I just want to get a render so that I can make sure that this actually works. Alright. Need it here. Nope, nope, nope. Yeah, let's connect this the easiest way we can. Set of uniform block. So I need to copy paste a lot from here. Uniform block. That is the uniform block. I'm gonna try to copy paste as much as I can just to get a render. After I get the render done, I will try to like extract out the structures here. Just trying to get the code working. Max planets. I need to see what that is here. Max planets. It is 20. Okay. I'm hoping the rest of the code isn't that complex, so I can easily get this to render something for me first before I actually need to do lots of bad code here. Why do we not have this here? I bet I copied it from here. How do we not have it here? Also, you kidding me? How would that be? Here it is. Okay, yeah, that was a problem. Anyways, yeah, I'm going to copy this buffer as well. Going to put it here. Yeah, we copy paste in the code. I need to make sure that this works first. PB buffer. Yeah, I don't know what the shaders are. These are probably dependent on the shaders. Camera controller. Oh no, I don't wanna build. We need this G API, now we done this. Pure render. So yeah, this does need to go in the render code here. So that is going to be update descriptor set, which is not going to be that much of an issue for us. It's going to be pretty simple. Update descriptor set. It is just going to take a descriptor set handle and it is going to do a reinterpret cast and update. Also, it's going to take another parameter here, which is to me going to be templatized on a stud size t. So this is the length of the parameter array. And it's going to be stud array. Yeah, I guess it's going to be stud array of. We don't have a stud array here. Yay, STL array. Of what was the type of that? Descriptor data. And of course my array length, which is going to be deduced. So you pass an array and it just works. But does it have to actually be an array? It only needs to be a container, type name container. It doesn't have to be an array. It only needs to implement like size and data. So let's see, descriptor data container, that is going to be. Yeah, we don't have concepts here. If you had C++20 available, that would be a good place to use concepts from C++20. Just to limit the types that can be passed as container. Yeah, we're back. We had some minor connection issues. Anyways, yeah. So that is going to call this with render putter.get. Then we're going to have the descriptor set here. Index. We're going to have an index here. What is that index then? Okay, we need to add stud size t index. That is also going to be const here. I'm going to break the lines there. Gonna pass the index and count, which is going to be one. Field is only one. It's interesting. That is an interesting abstraction they have there. So they're taking an array of descriptor data, I believe, which is that params here, and then they're using only one of it because there's a count here and there is an index, I believe. So could this actually be used? Yeah, that is weird. That is weird. I don't know why not just take balance. Oh, those are different things. All right, yeah, nothing. I just got weirded out again with the interface. Everything is back to sanity. Yeah. Okay. Then is going to be this data here, and then going to be the size. And I believe that is all I need to update the descriptor set. Let's just try it then, shall we? We added two descriptor sets here. We're going to name them. They were named. Let's just name. The first is going to be named texture. The other is going to be named uniform buffer. No, I don't know why they are named so. I don't know what they are used for at the moment. So I'm just copying the name from the previous code. So buffer uniform descriptor set. Yeah, that is it. I don't know why they were named so, but they were. So I'm just using their names. Okay, renderer. Let's see what this descriptor data has. Alright. Name and texture. Anyways, render. We're going to ask our render to update descriptor set there. We're going to give it the texture descriptor set from here. I don't know what. Yeah, I know why that needed to be done here. Alright, let's get to our code here. I forgot to do something here, I believe, and that something is this. The handle to our descriptor set. So this update descriptor set call takes the third parameter here. I am kind of confused at the moment. Oh yeah, it takes 5 parameters. I'm passing it 4 here. So this data is going to go here, and I am going to reinterpret cast this to descriptor set. So that's what I'm going to do, and I believe this is going to work now. Let's break the lines here so we can't see the code. So that is our render there, the index, and then the descriptor set itself, then the size of the data, descriptor data, and the actual data of the descriptor data. And yeah, I'm going to, what else does this function take? In this index and descriptor data. The index is 0 on this one, and then we have texture descriptor data. So I'm going to use ESTL array here. Array of descriptor data, and yeah, it's going to be of length 6. And I'm going to write the Lambda constructor here, which is going to look like this. Auto construct descriptor data, which is texture descriptor data to be more correct there. Oh, hello there, immortality. Yeah. So the reason I'm doing that is that this descriptor data doesn't have a proper constructor, and I'm gonna use this as a constructor because I am going to need to construct 6 elements here. That is way more than 6. That is 6. Alright, so what it's going to take as input is going to be a const char name, and then a const texture. So putter to putter. So a const texture, which is going to be like so. Alright, you're back. So yeah, I was trying to write a constructor for this descriptor data. We are already 7 minutes longer than what we should have been, but who cares? Let's just finish this, and that'll be for today. Yeah, so there goes that. I am going to just construct these, construct the descriptor data and return it. That is all I'm going to do there. Going to, okay, that is not what I was going for. Yeah. Alright. So let's do this then. Maybe I should have. That is 6. That is not 6. Law. Or was it? It was 6, I believe. Was it not? It was. Just want to get this to compile so I can actually validate that this new interface works. Right, that has to work. And then we're going to have a similar thing here, but this time rather an array of 1. Let's not do that. And that is the name there. So yeah, gonna remove that one. And the name is going to be, I don't know why this is compilation error here. I'm indeed missing something here. I don't know what that is. What is the error? Local variable const lambda. Oops, this is not the same with that. It is setting the buffer here. So maybe I will just do this. Gonna call the object descriptor from there. That is not going to be part of that. Where is this? Okay. And this is, we are already 10 minutes, 12 minutes over time. Let's just get this code to compile. We are just so close to getting a compilation. We are just so close. I don't know why we're, this code weirds me out a bit. Let me check the original one. This is virtually the same, and it's, why are we setting this again? That is kind of weird here. That is weird. I believe that's the same. Oh, that is not the same. That is not the same. Alright. Although, We are so close to get a compilation. Let's compile this. I hope this just works. Legal use of type as an oh yeah. Oops. Hello. I have so many minor issues here. Binding treated as error. No object file generated. Okay, yeah, conversion from this size T to. I like that. I like that. Static cast stud uinputters. No, not uinputter. Uinsert 32. That is that. That takes index as input. Does a proper cast. Spits it out. That should just work fine. But we have a problem here still, and that is of course here. So they're just not using size T as their index type, and that is not good. That is not good. That's definitely not good. Okay, I am also casting the wrong thing here. This is what I should be casting. Compile? Yeah, yeah.